Full adder. In this video, we discuss the full adder. A full adder is a fundamental digital circuit in electronics that performs the addition of three binary inputs and produces two outputs, a sum, S, and a carryout, C out. Why is it called full adder? It's full because, unlike a half adder, which only adds two bits and produces a sum and carry without considering a carry-in, a full adder accounts for a carry-in bit. This makes it suitable for building circuits that can add multi-bit binary numbers, like the numbers in a computer's processor. Now, let's look at the practical session covering the full adder circuit. Objectives. By the end of this experiment, you will be able to design a full adder circuit diagram using standard logic gates, example, and or XOR. Construct a physical full adder circuit on a breadboard or trainer kit using appropriate integrated circuits, ICs, and demonstrate its functionality. Verify the experimental outputs of the full adder circuit against its theoretical truth table for all possible input combinations. Requirements, tools or equipments or instruments. Digital Trainer Kit 1 number. IC 74861 number. IC 74081 number. IC 74321 number. Hook up wires as required. Precautions. Keep the power supply off initially. Do not apply excess voltage from the power supply to the circuit. Make proper connections as per the circuit diagram and avoid any loose connections. Full adder circuit. Circuit connection or procedure. Detailed steps for connecting the full adder circuit. Truth table verification. How to verify the circuit's operation against the full adder truth table. Power supply plus 5 volts is connected to the 14th pin of IC 7486. Interconnect 14th pin of IC 7486, IC 7408, and IC 7432. Similarly, connect ground to 7th pin of IC 7486. Interconnect 7th pin of IC 7486, IC 7408, and IC 7432. Connect input A and B to pin 1 and 2 of IC 7486. Then, connect a wire from pin 1 of IC 7486 to pin 1 of IC 7408. Similarly, connect a wire from pin 2 of IC 7486 to pin 2 of IC 7408. Interconnect pin 3 and 4 in IC 7486. Connect a wire from pin 3 of IC 7408 to pin 2 of IC 7432. Similarly, interconnect wire from pin 5 of IC 7486 to pin 5 of IC 7408. Connect input wire C in to pin 5 of IC 7408. Interconnect wire from pin 4 of IC 7486 to pin 4 of IC 7408. Connect a wire from pin 6 of IC7408 to pin 1 of IC7432. Connect output wire, sum to pin 6 of IC7486 and carry to pin 3 of IC7432. Now, let's discuss the truth table for a full adder. The truth table lists all possible combinations of the input bits A, B, C and their corresponding output bits, sum, Cout. There are 2 power 3 equal to 8 possible combinations since there are 3 input variables. Conclusion. The half adder and full adder are the building blocks of various digital circuits such as computers, calculators, digital measuring techniques. The advantage of using adders is that it is the part of the digital circuit, and logic gates form the backbone of the digital circuit, and they process the input very fast. The speed of processing by logic gates is in microseconds, and we need fast computation of results in almost every application, and thus, we use adders.